industrial operations produce significant wastewater requiring advanced treatment. This video explores an advanced industrial wastewater treatment plant, highlighting the cutting-edge processes, innovative engineering, and scientific breakthroughs used to purify this complex water for safe discharge or reuse. The journey begins with the collection of wastewater from various industrial processes within the industry. This wastewater often contains contaminants such as heavy metals, organic matter, and suspended solids. Pumps are used to lift the wastewater from the receiving chamber, ensuring a steady flow to subsequent treatment stages. First, the wastewater enters the screen chamber, where large debris and objects are removed to prevent clogging in subsequent stages. Next, the wastewater flows into the grit chamber, where sand, grit, and other heavy particles settle to the bottom. The wastewater then enters to equalization tank, where it is blended and stored to help stabilize flow rates and reduce fluctuations in contaminant levels. A jet mixer within the equalization tank ensures proper mixing and distribution of the heterogeneous wastewater. Before proceeding to the next stage, the wastewater's pH is adjusted to optimize the performance of subsequent treatment processes. After pH adjustment, the wastewater enters to pipe flocculator, where chemicals, coagulants, flocculants, and color removal are added to cause suspended solids to clump together. The flocculated wastewater then flows into the dissolved air flotation (DF) unit. In the DAF unit, tiny air bubbles are introduced, causing the clumps of solids to rise to the surface and form a sludge layer. The sludge layer is skimmed off from the surface of the DAF unit, removing a significant portion of the suspended solids. Sludge collector pipes at the bottom and top of the DAF unit collect the sludge layer, ensuring efficient removal of solids. The collected sludge is then transferred to the sludge thickener for further processing and dewatering. The clarified wastewater from the DAF unit then enters the rotating fine bar screen, RBS, a mechanical filtration device that removes any remaining suspended solids and debris, ensuring a clean water stream for subsequent treatment stages. After solids removal, the clarified wastewater enters the aeration tank for further biological treatment. Dissolved oxygen is introduced to the wastewater to promote the growth of beneficial microorganisms which break down organic matter and reduce mainly BOD and COD. The biologically treated wastewater then flows into the membrane bioreactor, MBR, a combined biological and filtration process. The MBR contains a membrane module that separates the treated water from the activated sludge. The waste-activated sludge will be directed to the sludge thickener, while the returned activated sludge will be returned to the aeration process to serve as a nutrient source for the bacteria. Regular cleaning of the MBR membrane is essential to maintain its performance. A membrane cleaning tank is used to periodically backwash the membrane and remove any accumulated solids. Treated water from the MBR enters the RO1 feed tank, where it's filtered through a micro-cartridge filter, MCF, to remove suspended solids. The high-pressure pump then forces the water into the RO1 unit, where semi-permeable membranes reduce total dissolved solids, TDS, reject water, or brine, is stored in the RO2 feed tank and filtered again through another MCF before the second high-pressure pump pushes it into the RO2 unit for further purification. The high-quality permeate combines with treated water and goes to a degasser to remove dissolved gases. The remaining brine from RO2 is sent to a high-rate solids contact clarifier, HRSCC, for additional treatment, then cooled and collected in the RO3 feed tank. Here, the water is filtered through a pressurized sand filter and another MCF before the final high-pressure pump forces it through the RO3 membranes, producing ultra-pure water for the permeate tank. The concentrated reject is directed to the MEE feed tank for further mineral recovery. The MEE is a highly efficient process that uses multiple stages of evaporation to recover water from the concentrated brine. By utilizing the heat from steam, the MEE can significantly reduce energy consumption and maximize water recovery. To provide the heat energy required for the MEE process, a boiler is used to generate steam. The steam is then supplied to the MEE, where it transfers its heat to the brine, causing water to evaporate and be recovered. The steam generated in the MEE process condenses back into water, which is collected in the condensate tank. This recovered water is to be transferred directly to the treated water tank for industrial use. The concentrated brine from the MEE is further processed in a centrifuge. This high-speed spinning machine separates the solid salts from the remaining liquid. The solid salts can be separated and will be stored at its desired place, while the liquid will be returned to previous treatment process units for further treatment. The degassed water from the combined RO1 and RO2 permeate, as well as the treated water from the RO3 unit, is collected in the treated water tank. This ultra-pure water can be used for various purposes within the industry, significantly reducing the plant's reliance on fresh water sources. The journey through the industrial wastewater treatment plant reveals the dedication and technology involved in safeguarding our water resources.